In this video tutorial, we're going to look at how to view and visualize data in RAMP. In RAMP, there are three main types of data that we can work with. The first, obviously, is raster data. That's image or gridded data, and that's the main data type that RAMP was designed to work with. The second data type is tabular data or relational data, such as spreadsheet data or databases. And the third is vector data. So this is data that is structured in terms of geometries as points, lines, and polygons. First off, we're going to look at viewing and visualizing raster data. So to do that, I go to the Rasters tab in RAMP. Now I need to read in a raster file. So I can choose one of my readers here, or I can simply right-click in the Layers area of the Raster tab and choose Add Raster. I'm going to choose my bathymetric dataset, and I'm going to open it. Once the dataset has been added to RAMP, you'll see that a layer is added into the layer listing, and there's a thumbnail here. In this case, it says there's no thumbnail. If I right-click on that, you'll also see that it says there's no rendering. So I need to render the raster in order to be able to visualize it. To do that, I right-click here where it says no thumbnail, and I choose the render option. This has applied a default color palette to the raster. So what I want to do now maybe is change that color palette and change how I've displayed it. So to do that, I click on the Display tab in the Rasters tab and click here where it says Edit Rendering Properties. This pulls up a dialog box where I can do a number of things. The first off is changing the color palette. So to do that, I click here on the color palette, and it displays the list or the graphical list of all the color palettes that are available to RAMP. There are currently 107 different color palettes. So I'm going to choose one that I'm happy with in terms of visualizing this particular raster. So I'm going to choose this one here. It's now added that color palette, and you can see it displayed along the bottom here, stretched to the histogram of the raster. So let's click OK. This has now applied that color palette to this raster, but you can see that it looks a little bit boring because there's a linear stretch applied across the histogram, and the histogram is not even. It's predominantly weighted towards the lower end of the values in the raster here. So let's change that. One of the ways I can change it is to change the rendering method here. So I have a number of different options. I'm using the linear minimum and maximum to stretch the color palette across the entire raster linearly, but I can also equalize it. What that'll do is it will put equal number of raster data, or equal amount of raster data for each color within the color palette. You can see now that my color palette has been stretched and skewed so that most of the color is evenly distributed where most of the data is. If I click OK now, it'll apply this new stretch using the histogram to my raster. Okay, that starts to look a little bit better. I have a more even change of colors, and I'm starting to see different features within the data set. I can also choose to stretch the data in different ways. So for example, I might choose split points or user-defined split points. Now what this is, it allows me to change the minimum and maximum values and also change the points to which they're stretched. So what I'm going to do is I'm going to choose pick splits, and every time I pick a split I need to put a line on the map there, pick a split again, put a line on the map there, and as I'm adding them you can see my color bar color palette stretching. I'm going to put one here as well. Now let's have a look how this looks. So I'm going to click OK and apply this stretch now to my rendering. Okay, it looks a little bit different, not quite as bad as the linear stretch, but not as easy to look at or as well distributed as the equalized stretch. I have a number of other ways to add splits. So for example, I'm going to now reset the splits by clicking clear splits, and I'm going to statistically define my splits. So I can give either specific values for the splits, or I can say, actually, I want to put splits at 0.5 standard deviations, 0.7 standard deviations, 1 standard deviation, and 2 standard deviations from the mean. So I'll click OK now, and you'll see that it's applied all those splits across the data. Let's have a look what this looks like now when I click OK. Alright, you can see that it's changed slightly the stretch of the color palette to the raster. Now, one of the things you may have realized with RAMP is that there's no actual means of zooming in and having a look at the raster data set in any more detail, and that's intentional. RAMP is not designed as a interactive map system. The visualization here is purely so you can see the results of your processing in RAMP. There is a trick, however. I can choose to clip the raster. By clicking this button here, I can then choose a specific area of the raster that I want to clip. What this does is extract the area that I've defined and create a new raster. So this is a little bit of a cheat way to do a zoom in. So I'm going to now, it's added the new clip in here, and I'm going to render it as I did before. And now I can see that particular area that I've clipped out, and I can do the same thing. I can choose a new color palette, I can equalize it, and I can re-render it and have a look. So that's the sort of cheat way to force RAMP to zoom in and zoom out as you would in a more traditional map viewing system. But if we really want to interrogate, zoom in, and pan around a particular raster, the better strategy is probably to add it to a GIS package such as ArcGIS or even QGIS. So let's look at how we might take this raster and use it in QGIS. So here I have QGIS running on my computer, and I'm going to add a raster layer. So the simplest thing I can do is simply add the data set that I just used in RAMP. So I'll do that first. Let's add the original data set. Okay, you'll see that it's now added that raster data set into QGIS, and I can zoom in and zoom out like I would in any GIS package, and I can change how this is rendered using the rendering properties that are available in QGIS. So let's look at the symbology. I can change to a pseudo color data set and apply here, and I see it changed in QGIS. However, what if I'm particularly happy with the way I've rendered something in, say, in RAMP? So let's take this data set here, the clip. I might be particularly happy with the way this looks, and I can't necessarily reproduce that easily in QGIS. So one of the things I can do is simply right-click in here and save rendering. So I'm going to save the rendering, and it's going to ask me to put it somewhere, so I'm going to say here. I'm going to save the rendering as a PNG file, and it's going to be called rendered clip of site bathy, and I'll put it with my other data. If I go back to QGIS now, I'll turn off this particular one, and I'm going to add a layer again. This time though, I'm going to choose my PNG file. You'll notice that the PNG file I created also comes with an accompanying PGW file, which is a world file that tells most GIS packages where to draw this image in a spatial sense, in a real world sense. So if I click on the PNG now and add it, you'll see that it has in fact added that rendering in as I rendered it in RAMP, and I can put that on top of the other image that I put into QGIS. Now you will notice that this is at a lower resolution. If I want to save the rendering that I just created at the full resolution of the dataset, I can simply go back to RAMP, and instead of choosing save rendering, I can say save full resolution rendering. Now, it gives me a warning that this could take some time to render, so I'm not going to do it here today, but if you wanted to render it at full resolution, you could choose this option. So that's a little bit about working with raster data and visualizing them in RAMP and how to interoperate with the GIS package. Let's look now at tabular data. That's the other data source or type that RAMP deals with. And we mostly use tabular data in RAMP because we want to use it to supplement a processor that needs tabular information, or we might want to bin and grid that data into a raster. Tabular data in RAMP is actually implemented as what we call a standardized ASCII CSV file. So it's an ASCII comma-separated value file that has one header line at the top. So first off, I have a CSV file here. I'm going to open it up and you can see what it looks like in Excel. It's got 4 columns, X, Y, distance, and value. And these are coordinates, and these are distances along a profile, and this is the value at that profile location. So very often you might be dealing with very large data files that Excel can't actually open itself. So as a visualization tool, we've created the ASCII data inspector, and it's a tool in RAMP. That allows me to visualize any ASCII file. So I'm going to go back to my sample data here, and I'm going to open it up. This is smart because it only reads a certain number of records at a time, so it won't take forever to load the data into your data inspector like it might in, say, Notepad or another ASCII viewer. Because it's deemed that maybe 500 lines is enough for you to inspect the data and have a look at it and see how it's structured. I can, though, say, well, let's look at the last 500 records. So if I go here, end of file, it's now going to load the last 500 records of the data set. So I can see what the data set looks like at the end of the file as well. Okay, so this is all a little bit hard to look at. If I go to the next tab across standardized ASCII CSV data, I can load the same file again, but because I've told it it's a standardized ASCII CSV file, it now knows how to create the rows and columns. So I can inspect the data in this way as well. Now let's have a look at vector data. So there are a number of processes in RAMP that either generate GIS vector data in the form of shapefiles or consume vector data as shapefiles. RAMP itself doesn't have a means for viewing these vector data sets, but the standard for RAMP when it wants to work with vector data sets is in fact an ASCII shapefile. So really, I need to go back to QGIS or one of my GIS packages to visualize the shapefiles. So I've previously used the export ASCII shapefile method in the profiling processor, and it's exported a shapefile. I'm now going to go to QGIS and add one of those shapefiles in and see what it looks like. So let's do that now. And I think I have this one here, profile line. And indeed, it's shown me where those where the profiles I've created are as a shapefile on top of the rasters in QGIS. So that's a real quick overview of how you work with and visualize data that is coming in and out of RAMP. I hope the tutorial's been useful.